Hello everyone. Today we will learn drift velocity. What is that? Drift velocity. So what is this drift velocity? So first of all, let me tell you about the definition, how we can define this drift velocity. It is the average velocity it is average velocity acquired by free electrons acquired by free electrons okay, it is the average velocity acquired by free electrons inside a metal inside a metal by the application of an electric field which results in current. This is what the definition is. Now, first of all, let's try to understand this drift velocity is what. For that, what I am doing, I am taking a conductor and I am showing you how the changes are taking place before application of electric field and after application of electric field. Like this conductor is there. This is, let us suppose, before before applying potential. The case one. And in next case, I am taking the same conductor, but we are applying potential difference now. means battery we are applying. Yes. So what we did here, we have applied the potential difference, that is P. The second case, and this is after applying potential. Now see here, what happens? Now this is a conductor, okay? This is a conductor, but there is no potential difference applied to this. So initially in this conductor there are so many atoms. So many atoms are there. So this is the atom, and this is atom, and you can say nucleus, and around this so many electrons are bounded in different states. Like so, this is a nucleus, and around this so many electrons are there. Like okay, like yeah, yes. At least so many electrons are there. This is nucleus, atoms. This whatever you can see. These all are atoms only, and these small are the electrons. Okay, very few I am drawing so that you will understand. Like that, so many are there. Now, what happens? So, initially, what happens? The valence electrons are there, no? This electron will go here, okay? This electron may go here, this electron going here, this electron going here, okay? Like some so many electrons are going, and they are colliding with positive ions, okay? Why it is happening? Because of thermal energy. Because of thermal energy. These electrons, free electrons, free electrons collides with with positive ions, and therefore average velocity, we can say average velocity, that is u1 bar plus u2 bar plus u3 bar plus so on plus up to un bar divided by n is equal to 0. Or not? Why it is coming 0? Because all the electrons they are colliding with positive ions, and therefore the average velocity is what? 0. Is when it is potential is not applied. In the first case we can say. Now in the second case you see, after applying potential, what happens? Now these all free electrons, because you have given this positive potential here to this terminal, so let us keep some names also for this conductor particularly. This end is A and this end is B. Okay, this end is A and this end is B. Now, here at this point, how current will flow? Current will flow from positive terminal of battery to the negative terminal of battery. Yes or not? This is your current direction. You can see that. Yes, this is what current direction. Now, how the electrons will flow? How electrons will flow opposite to the current direction? Yes or not? So all electrons are moving in this direction. Yes or no? Isn't it right? This is what electrons, and this is what current I. And let us suppose the length of this conductor is how much? L. Now you see electric field direction is how from positive to negative. You can see here. This is what your electric field direction. This is again your current density direction also. I will tell you again what is current density. E bar, J bar, and similarly you are having this as also current direction, isn't it? Where is your current? Current is also flowing in that direction. Yes. So this point I will write below so that you will understand. And drift velocity is where? In this side. You can see. What is this? Drift velocity direction. This is what drift velocity. This side. So see current, electric field and current density. क्या क्या है? Electric field, yes, current and density in this side. So I will make one picture for your understanding. Assume that there are, or you just think like this, that this is a rope, we can say. Okay, so one is in this direction and these three are pulling this direction. Okay, right? This rope, one person is pulling this side. So what is that? Drift velocity. And this side who is there? Current, yes, electric field and current density, isn't it right? Yes or not? Electric field and J bar. In this particular, I have not kept for this current I as a bar. Okay. So E bar and J bar. And this side drift velocity is PD bar. Because these two are the vector quantities, electric field, current density. And here it is PD. What is that? Drift velocity. But in this diagram, current, electric field and current density are in this direction. Drift velocity only alone is what? Where? In this direction. This is what about the diagram. Now, what is this average drift velocity? You can see it is the average velocity acquired by free electrons inside a metal by the application of electric field. Yes or not? So, whatever the velocity acquired by these free electrons, yes, you can see here these green arrows are there. No, these are what? Just free electrons. They are moving here and there. They are colliding with positive ions when before applying potential. But when we are applying potential, all are moving in same direction. So this is what, with what velocity they are moving, that is called drift velocity. Yes, after application of this electric field. Clear? So note down this all. Yes, finished? Okay. Next. Now, see here. Due to electric field, due to electric field, due to electric field, you are getting one electrostatic force, we can say. F force. F is equal to Q into E. Or due to electric field, I am writing like this. There is electrostatic force. There is electrostatic force. And that electrostatic force is what? F is equal to QE. But here charge is what? Electrons. So F is equal to minus E into capital E, where charge is what? Charge on electron, that is equal to minus E. Therefore, F is equal to minus E into E. Now we know F is equal to what? MA. MA is equal to minus E into capital E. What is this? Electric field. What is this A? Acceleration. If I want acceleration, then it is equal to minus E capital E by M. As this is vector, then I will keep like this. A bar is equal to minus E bar by M. This is what we got. Acceleration. Let's call it as equation number 2. And the one previous, which one you got? No, average velocity. You can call it as equation number 1. Okay. This equation you are having, no? Yeah, average velocity. You call it that as a equation number 1. And this one is what? Yours equation number 2. That is A is equal to minus E bar by M. Now, initial case and final case, can I write like this? That is VD is equal to VD is equal to what I am writing, you see. I am writing like this, that we have one kinematical equation, that is V is equal to U plus AT. What we are having equation? V is equal to U plus AT. Yes or no? So can I write like this equation then? PD bar is equal to U average bar plus A bar into tau. So PD bar we want to find. U average is already 0. This plus A bar is here minus E by M into tau. So therefore we are getting PD bar is equal to minus E by M into tau. This is what? One formula we got for this drift velocity. Where T is what here? T is called relaxation time. What is this? T, relaxation time. First formula I got, PD is equal to minus E by M into tau. Now what is this relaxation time? Yes, what is this relaxation time? How to define this relaxation time? So relaxation time means when these two electrons are colliding, no, in between, yes or not? So we can say time between two successive collisions. Time between two successive collisions. Right or wrong? So what you are getting? PD bar is equal to minus E by M into tau bar. This is what your drift velocity. Okay, note down. Now next. Now, if I want the formula in terms of current and area of cross section and all, then how I will get the formulas in terms of this resistivity and all. As you can see here in the first diagram, there is length PD. Then let us suppose A is the area of cross section of this conductor. Then suppose rho is what? Resistivity. So I am writing here note point after this. You can see what is that note point. It is very important for problem solving. If n is number of electrons per unit volume, if n is number of electrons per unit volume of the conductor, next one, A is area of cross section of conductor, area of cross section. P is what? Capital V, potential difference, means the battery of it, how much potential you have used, 2 volt, 4 volt, 6 volt, 9 volt, 20 volt, whatever it is, like that. So this is what? Potential difference. This is not velocity, yaad rakho. Potential difference. E is what? Electric field. Electric field. Yes. And that is inside the conductor. Next. And I is current, suppose. Then number 1, PD is equal to I by N E. PD is equal to what? I by N E A. Next one, that is also equal to capital E divided by rho into N into E. Okay, that is equal to P by rho L into N E. That is also equal to J by N E, also equal to sigma E divided by N E. Now there are two more new terms we can say. Rho is what? Rho is what? You know, resistivity. Yes or not? Resistivity means rho. You know, no, ohm meter. R is equal to rho L by A. In 10th class also you have learned R is equal to rho L by A. This is called resistivity. Resistivity or specific resistance. Another name is what? Specific resistance. Okay. Can I write here? Okay, I will write here. Wait. Or resistivity or specific resistance. Okay, sir. This row we understand. E electric field. N is number of electrons per unit volume. E is what? Charge on electron. P is potential, rho is again resistivity L N into E. Why? Because here E is equal to what? V by L I have substituted. Keep it in mind. E is equal to V by L. Electric field is equal to potential difference by length. Then this is J. J is what? Again, new concept. This is a new term. J is called current density. I will tell you in next thing only. Next board we can say. Current density. And sigma. Sigma is what? Conductivity. Conductivity means what? Reciprocal of resistivity. है ना? Reciprocal of resistivity. So this is what? Common formula for this drift velocity. You keep it in mind always. Don't forget. Right? Okay? Understood? So note down. Note down fast. Yes, finished. Okay, let's move ahead. Now next. See here, as we have learned this drift velocities formulas, you keep it in mind, whatever they will give according to that, you have to use the formula. So let's move ahead now. Now, first point, what you understood, drift velocity is proportional to electric field. याद रखो. And second point, drift velocity is inversely proportional to area. Right? Okay. Drift velocity is inversely proportional to area. Keep it in mind. Right? This is finished about drift velocity. Next one we have learned, that is one new concept came now, is current density. So let's see what is this current density. Right? Current density. It is denoted by J bar. It is also vector quantity. Okay. So we have used now in formula. So what is this current density? This current density is nothing but, we can say, current per unit area. What is that? Current per unit area. Okay. So let me draw one small diagram for your understanding. Let us suppose we are having a small conductor. You can see that. This is a conductor, and I am taking its cross-sectional area through which these electrons are flowing. This is a conductor. Now, this is what your current direction is. Okay. And if suppose I am considering some area that is, which is in this direction, right? So let us suppose I am taking very small area. You can see this shaded part. This one is dA bar. And through this area, let us suppose current is di, okay, di. Then here J is equal to di by dA into n bar, which is J bar. What you understood from this? Listen, this is the conductor, okay? And through this conductor, total current is I. I is flowing through that conductor. Now what I am doing, I am taking a small cross-sectional area, that is dA bar, in this direction, okay, which is like this. How we can say? This is the current, and like this area I have considered this area, okay. So if I am considering this area as a dA, and through that area element, small area element, current is di, then J bar is equal to what? Di by dA into n bar. N bar is what? Just direction it indicates. Okay. If you want, you can note down here also n bar. N bar is what? Direction of. Okay. This is the case 1. Right? In this case, it is along. Now, if in the second diagram you see, second diagram, what I am doing, again I am taking one conductor like this, but this time I am changing area of cross section, which is I am taking by making an angle theta. If it is making an angle theta, so you can see here. Now, if you will see this part, and if I am drawing one perpendicular to this area element, you can see this is the perpendicular to area element. Keep it in mind always. This is very very important thing. Okay. जैसे कि अभी ये देखो, ये झंडा गाड़ते हैं ना हम लोग, ये कैसे रहता है? इसको परपेंडिकुलर रहता है. You don't know what we can say. In choke particularly, or crossroads, you can say. Flag hosting, there will be one rod and down one disc will be there. No? How that rod we are piercing into that perpendicular, like that, that area element also we have to take. Understood now? I hope you understand now. Yes, how it is perpendicular like this. That only, that area only you should take like this, perpendicular to this disc. Flag hosting का वो rod और disc याद करो. Okay, like that. So here, now where is your current direction? You see, as usual, as in the previous case we have seen, this will be your current direction. Yes or no? How will be the current direction? This is the current direction, as usual. So this is the current direction. So if I want to take angle, then I should take with respect to current. So this will be your angle now here. Yes, this is current, and this is what area element. This angle is what? Theta. In this case, both was in a same direction. That's why you got like this. So here what we should do, this is your dA bar we can say, and this is what? J bar, or you can take, so this component if I am resolving, what I am getting this component dA cos of theta, and this component which is in vertical direction we don't want also, but still I am resolving for your understanding. You can see here, this component we don't want, but still I am giving dA sine of theta. We don't want this. We want only this, which is along the direction. This is current direction. Current direction, current density direction, this side. So in this case, if I want J bar, then J bar is equal to what you will get? EI divided by EI divided by what you will get? dA cos of theta. I am not writing vector here. Okay, fine. I will tell you. Wait. Now he see Now I want di, so this is equal to j dA cos of theta. Okay, so I am not keeping here also bar for some time. Wait. So this is like a dot product, yes or not? So can I write now here like this? Di bar. Okay, I will write here. Di is equal to j bar dot dA bar. This is what vector product. And therefore, if I want current, I am integrating on both sides. So therefore, this integration is equal to integration of j bar dot dA bar. Okay, these formulas we have to use in these type of cases where it is making area or angle theta with the area of cross section. This is what condition number 1. This is what condition number 2 we can, right? Okay. Note down next way. Now see here. Basically, what is the formula? J is equal to I by A. This is for what? Uniform current and area of cross section. Okay. For uniform flow. Now, this is equal to I by A is equal to. Can I write like this? See here. N into Q into V. But I wrote C. N into Q into V. See what I did. I will tell you. This side you can see. I by A. I can write like this. I is equal to Q by T divided by A. Okay. So this is Q is equal to what? NE, quantization of charge. NE by T by A. Okay. Understood. Now this is NE by T into A. Yes. Then what is this phi here? N is number of electrons. Yes, N is what? Number of electrons. N is as it is. E by T we are having, and just we have substituted what their velocity. तो अब देखो क्या होता है यहाँ पे I by A किया है ना? Yes. तो NE by T by A आ रहा है अब. NE by T by A. So if I am substituting number of electrons per unit volume here, and if I will take that area into length and then length by time here, this area will get cancelled. L will go up. So L by T, and hence we are getting NE there. Okay. So you can do that, right? Just do that. You will get NQ. Okay. Now another formula in terms of current density we can say, that is what? J bar is equal to sigma into E bar, and also E bar by this sigma is equal to what? 1 by rho, you know. Therefore this is what? E bar by rho also. So these are the some formulas of current density. You can note down. Already I told you sigma is what? Conductivity. Rho is what? Resistivity. Sigma is equal to, or this rho is equal to 1 by sigma, or Sigma is equal to 1 by root. This is what? Conductivity. This is what? Resistivity. Okay, conductivity and resistivity. Okay, one problem I am giving you for solving, try yourself, and then we will stop here. One problem on this drift velocity, you try yourself. Yes. So what is that problem? Very easy. A copper wire of cross-sectional area, a copper wire of cross-sectional area 2 millimeters square. You have to convert into meter square. Keep it in mind. Resistivity, that is rho I am writing, 1.7 into 10 to the power minus 8 ohm meter, carries a current of 1 ampere. The electric field in the copper wire is, the electric field in the copper wire is, that is what? Capital E bar we have to find. Okay. So area you have, rho you have, I you have. So which formula you will use and how you will solve, that is your talent. Okay. So do it, and its answer also I will give you. Its answer is, so that you will get to know. Its answer is 8.5 into 10 to the power minus 3 volt per meter. 8.5 into 10 to the power minus 3 volt per meter. This is what answer is. Okay. So check it. Try yourself. 8.5 10 to the power minus 3. Okay. We'll stop here. Enjoy the day.